Hello, I'm Sun. I'm going to present our work, Disentangled Left Span Face Synthesis. Given a face image of a person, left span face synthesis aims to generate the whole left span face images of this person. Left span face synthesis has many applications. It can be applied for entertainment on social media. For example, the TikTok aging filter and the Snapchat time machine. It can also apply it in cross-age face recognition, retrieval, and finding lost children. Left span face synthesis is a quite challenging problem, because doing the whole left span face has two highly nonlinear changes. In early ages, for example from baby to adult, the change is dominated by shape due to the growth of scar. Then from adult to elder, the change shifted to texture transformation, for example the wrinkles and the color of hair. Previous methods treat this problem as a domain translation problem, where they usually use a convolution encoder to extract the face feature and then apply some transformation to the extracted feature condition on the target edge. However, the extracted face feature is an entangled representation, which includes identity, shape, and texture. When the transformation is applied to the entangled representation, it is inevitable to add some unnecessary transformation. For example, in the younger age group, it may add a texture transformation which will result in unrealistic effect in the output image. To address this problem, we propose disentangled left span face synthesis. The key motivation is to disentangle the face representation into three factors, namely shape, texture, and identity. During the left span transformation, we explicitly model the two different transformations of shape and texture, while keep the identity unchanged. More specifically, our model has two inputs, the reference image and the target edge. We use a convolutional neural network to extract the shape, texture, and identity, and an embedding module with several fully connected layers to encode the target edge. Then we separately transform the shape and the texture condition on the target edge. Specifically, we apply modulated convolution to transform the shape feature and the channel attention to transform the texture feature. The transformed shape and the texture are fed into a Stilgan-based generator for target image generation. We apply a conditional adversarial loss on the target image to train the network. To help the disentanglement of shape, texture, and identity, we exploit two properties in the left span face transformation. The first one is constant identity. We add one regularization between the reference face and the generated target face, such that for any given target edge, the generated face should have the same identity as the reference face. As the shape is usually unchanged between elder groups, so for any reference face and the generated target face in the elder groups, we add one regularization between them, such that they have the same shape feature. With the shape and identity regularization, we can disentangle the shape and identity feature, so the another remaining one is texture feature. We can experiment our model on FFHQ aging dataset as per standard in previous work. During training, we cluster the dataset into several age groups. Then we only use 6 age groups for training, and we train the model for male and female separately. Overall, our model achieves better performance than previous work. In particular, our model is better on shape and texture transformation, reconfiguration, and has better edge accuracy. Here is the qualitative comparison with previous SOTA method. Clearly, our model in the last row can better synthesize left span face images. We first check two length transformation. At first, given the reference image, we only transform its shape feature. We can clearly see from the result that significant shape transformation among younger groups and a few texture transformation among elder groups. Then we add the texture transformation. Clearly, we can observe wrinkles appear among elder groups. Importantly, the transformation of texture only has little impact on the shape among younger groups. To conclude, in the paper, we propose a disentangled left span face synthesis. The key idea is to disentangle the face representation into shape, texture, and identity. We use modulated convolution and channel attention to model the shape and the texture transformation, respectively. Extensive experiments show that our model achieved a superior result over previous SOTA methods. So thanks for your watching. If you have any further problems, please drop me an email or raise an issue on our GitHub.